Hello everyone, welcome to today's tutorial on partial fractions. We know that in mathematics we can have algebraic fractions. For instance, 2x plus that and plus let's say 1 over x plus 1 plus x minus 1 over, for instance, x squared plus 2 plus 1. Okay, so we know if we want to add them, we can add these two first before adding it to that one. We will now have we'll get the LCM, which is x1 x plus 1 for these two, and have 2 times this 2x plus 2 plus x minus 1 plus x minus 1 over x squared plus 1, so that we can now write it this form: 3x plus 1 all over x, this time is x squared, minus 1, this time is 1, this time is plus 1 will cancel, so you have that plus x minus 1 over x squared plus 1, which when taken further will give us we also do this x squared minus 1 x squared plus 1, so that if this goes here, it will remain. The distance is, you have 3x cube, this time is 3x cube plus 3x plus x squared plus x squared plus x squared plus 1 plus 1. That is, this time is x squared, this time is 1, plus this time is x cube minus x cube minus x, then minus x squared, then this one plus 1. That's what we have. So that if we add that, we'll have 4x cube, this and this, 4x cube plus this one will cancel this one, plus 4x, this and this will give us 2x, 4x, 2x, 2x, this and this 2x, this and this 2 plus 2 all over. If we multiply this, we get s raised to power 4, this and this minus 1, this times this and this will go. So that is what we have, which is equivalent to p of x over q of x. So this is polynomials. P of x and q of x are polynomials of degree 1 to higher order degrees. So if the degree is 1, it is linear. If the degree is 2, it is quadratic. If it is 3, it is cubic. And if it is 4, it is quartic, etc. So let's now assume that a partial fraction in this form is given. So first of all, we have to know the rules, because the denominators don't have the same type of degrees. For instance, this one is degree 2, this one is degree 1. It can happen that it is other degrees and other forms, or a mixture of it. So the first thing we'll do is to look at the rules. Rule 1. So if the first degree, if p of x is greater or equal to q of x, we divide this equation in order to make the denominator divide, in order to make p of x less than q of x. Okay, for rule 2, if we have the quotient, that is the denominator, to be equal to x minus, to have linear, let's say linear, comma, factors a2, a3, an. If they have linear factors, that means that our P of x over Q of x will be represented as this. Let's say y over x minus an. That's root 3. Root 3, if we have repeated factors, where we have a Q of x, repeated factors, I say, let's say x minus a raised to power n. So that means that our P of x over Q of x will be a over x minus a plus b over x minus a 2 plus c over x minus a 3 etc. So that we will now obtain it. So if we have for instance a quadratic factor in the denominator, for instance ax2 plus bx plus c, that means now that our P of x over Q of x, we'll take that into consideration and we'll write it in this form over that quadratic plus c. We can also have repeated quadratic factor. If we have repeated quadratic factor, if we have repeated quadratic factor, then let's say we will now have P of x over Q of x to be ax plus b over the first one plus bx plus c plus cx plus d all over ax squared plus b plus c all squared. That's for repeated factors. Now, having known all this, we can now try to resolve this problem back to see if we will get this. In order to do that, in order to resolve this equation into partial fraction to get where we started, we will now say 4x cubed plus 2x plus 2 all over s4 minus 1 is equivalent to, first of all, we know we can factorize this into order 2 minus 1 squared plus 1. Then we now have it as if you like cube plus 2x plus 2, and it's equal to ax plus b all over s squared minus 1 plus cx plus d all over s squared plus 1, where we have made use of this type of rule 4. So if we do that and open up here, we have s squared minus 1, s squared plus 1, so that we have 4x cubed plus 2x plus 2 is equal to, let me use blue biro, so that we have, if this one divides this, we have this times this, that's a cube plus ax plus bx squared plus b plus cs cube minus cx plus dx squared minus d. So that's what we have. We can now equate, we can now say equate powers of x, power of x cube on both sides, If we do that, we have 4 on this side and a plus c on the other side. So we have a plus c is equal to 4, equation 1. For powers of x cube, for power of x squared, we have that b plus d is equal to 0. B plus d is equal to 0. There's no x squared here, so let's call it equation 2. For power of x, we will have that a minus c is equal to 2. A minus c is equal to 2. So we have it and write equation 3. So for no power or x naught, if you like, for no power or x naught, so 2 is equal to b minus d. B minus d is equal to 2. Let's call it equation 4. So having called it equation 4, we can now get from here that from 2, we can get from 2 that b is equal to minus d. And if b is equal to minus d, we put minus d as b here and get b plus b is equal to 2, which means that b is equal to 1. And if b is equal to 1, then d is equal to minus 1. So d is equal to minus 1. So from our equation, 1 and 3, these two equations, we want to eliminate c. So we add these equations. If we add these equations, we'll get that 2a is equal to 6. 4 plus 2, 6. This implies that a is equal to 3. So a is equal to 3. And we can go back to 1. We can go back to equation 1 and say that therefore 3 plus c is equal to 4. 3 plus c is equal to 4, which implies that c is equal to 4 minus 3, 1. C is equal to 4 minus 3, 1. So with this now, it means that our partial fraction for, therefore 4x 3 plus 2x plus 2 all over x4 minus 1. That's this one. That's what we are resolving. We now we substitute for a, will now be equal to a is 3, x, b is 1, 3x plus 1, I think b is 1 over x squared minus 1 plus c is 1, so it will be 1 times x plus, okay, d is minus 1 all over x squared plus 1. But we cannot factorize this one easily, so but we can factorize this one, so which means we are going to resolve this one further into partial fraction. Let me fit it somewhere here. We will now say that 3x plus 1 all over x squared minus 1 is equal to a, because it has a linear root, plus b over x plus 1. This time this will give you this, so they have linear roots. So we can open it up, x minus 1, x plus 1. So you have 3x plus 1, 3x plus 1 is equivalent to this one here, ax plus a and plus bx minus b, bx minus b. So from here now we see that for powers of x, we have that a plus b is equal to 3. And for no power, we have a minus b is equal to 1, isn't it? So let's call this equation 5, and this one equation 6 for reference purposes. So we have, if we add this to eliminate b, 4, 0, 2a. This implies that a is equal to 2. So if a is equal to 2, it means that b from equation 5, it means that b is equal to 3 minus a, which is equal to 3 minus 2, which is 1. So it is 1. So having gotten that, we will now see that the whole of our problem, which is this, which we have set out to solve, is 4x cubed plus 2x plus 2 all over x4 minus 1 will give us, is equivalent to, let me write it in red. For this 3x over x squared, we have resolved it into 1 over x minus 1 plus, okay, ba is 2 over x minus 1, and b is 1. b is 1 over x plus 1, plus, if we now add this one, remember the whole of this is this, the whole of this is this one, so we have written it plus this one, x minus 1 over x squared plus 1. That is exactly the equation that we started with. This equation is exactly the equation that we started with in order to prove that we can resolve all these things into partial fraction when we know a function p of x over q of x. So it means that we can do that. We can have fractions in algebra. Thanks. Please subscribe and click on the notification button so that whenever we post new videos, you will see it. Thanks. Bye.